Okay, so today we're talking about how you can level up your migrations or your migration engineering by using advanced techniques in OpenRewrite. Little disclaimer, I just dive a little bit, dip our toes into the basics of OpenRewrite because I think on the YouTube channel there's still the talk for my colleague Tim Tabik from probably last year around. So if you want to have the basics, go to this talk. We will have a little bit of basics to get us all started, and then dive deeper in stuff that it usually don't make it into the first hour of OpenRewrite sessions. But it's the real beauty of OpenRewrite. So who am I? Talked a lot about me. I'm Merlin. I'm a staff software engineer with Modern for the last half year. I'm talking about OpenRewrite, modern Java, and in general modernization for 3 years now. And whenever you have something with OpenRewrite at the moment on conference, it's probably me or my colleague, Tim Tabik. So, but if you want to join, no problem. We have a lot of stuff to do, as you might imagine, because migrations is a burning topic in the last years. Besides, I'm a JUG organizer from JUG Dortmund, so it wasn't that far from me from now on. I'm an Oracle Ace and re-elected there. Whenever you want to have something up to date, get to mbögi.dev. I will publish the slide there as well. And you're welcome. So, what's OpenRewrite? So, where it is coming from? Yes, it's coming from Netflix. No, Netflix is not involved here. It was just a few engineers of Netflix, namely Jonathan Snyder and a few of his friends, who were in the platform team and were very annoyed by their engineering teams not picking up their API changes. They kept involving the API, but had to maintain old version back to a few years old because all of the engineering teams refused to update because they have different things to do. And they heard very often the phrase of, if you do it for me, I'm happy to accept. So they built a tool, OpenRewrite, to exactly do this. Do these large code changes nobody want to do on their own. On an automated way, on a rule-based way, so it is deterministic what change is to be done, and it's idempotent. Once the change is done, it's not done twice or third or fourth times. It is possible to define recipes who do this, yes, but there should be a test against it. So that's basic ruling there. And yes, it's test driven, so it's all that engineers want. How does it work? This representation of, I have a new pointer, I have to use it. This representation here, sorry, this representation, this one, sorry, this one, this is a representation you probably all know. That's the text-based representation of a program. It is intended to be readable by humans. Some languages more than others, but all intended for humans. And it's very chatty. Even though this source code here is not very chatty, it is too chatty for a compiler. The compiler compiles the abstract syntax tree out of it. No class names, no variable names, no intentions. Probably there's no if. There's just a go-to with a guidance, with a rule on top. That's the abstract syntax tree. It's not intended for humans. It's only intended for computers. But the big problem is, once you have the AST, there's no way back because there are missing informations. No comments, no names. That's what the lossless semantic tree on the right is about. That's what OpenRewrite builds on top of, works on top of it. You see every blue dot here in the left, it's the same AST. The LST is just the AST with variable names, with intentions, with comments, with compile time, annotations, and everything we can read in a human readable style is available there. Has two big benefits. First of all of our semantics are encoded there as well, computer readable. Plus, we can find there's an easy projection back from an LST to the exact same code here, which can produce a diff. So we have a minimal change there for our pull requests. Now we have this tree. How does it work? We are working there with, we are building this LST and working there with visitors because it's a tree. In computer science, it's always a visitor if you have a tree. So we have this list, this method call on static method call, which is basically an expression, which is a special kind of expression. It's a method call. We have a few identifiers there. We have a few literals there. And then there comes this visitor and visits all of these elements. And on all of these elements, this element is available. Have a look at it and decide what to do. Probably change some of them, probably not, and you're on the same page. You're on the new source code. And there are methods for everything. And there are a lot of stuff in language specification that you're probably not aware of. There are a lot of them. So, last thing on recipes and how they are written. We have 3 types of recipes. 2 of them we will see today. First of all, there are the declarative recipes. It's a very easy style of YAML. It's basically a configuration of take this recipe, and please use this variable name, compile scope, whatever. They are very simple building blocks and they are dump on intention. So there is no if in there on intention because they're just declarative, read it down. There's this refaster style. I don't want to go into detail here. It's more of an annotation-based style, borrowed from Google's error prone style, where you just denote, take this method call or this semantic block and replace it with this block. It's that easy. What we will see today mostly are the imperative recipes. That's the very base recipe stuff there. But it's a very powerful stuff there because you have visitors for every language that is supported with visitor method to change to manipulate this LST element and have different ways of creating new LST elements and working with them. Now we're basically done with slides. We may come back to slides in, we're 10 minutes in, probably half an hour. And because Mac updated their display settings, I now have to, yes, you're still seeing what I see. So now we are trying to have a little bit of recipe basics. No, not recipe basics, advanced recipes. We start with something for what you might need the presentation mode. So we want to write a recipe. And like every recipe we write, we want to do this test driven. So for OpenRewrite, we have this test harness where we implement this rewrite test method. We have a default method where you're just creating, I want to execute this recipe here. And then we are declaring in a declarative way, giving our tests here. It's very easy. It's an JUnit integration and fully integrated with IntelliJ. So we run OpenRewrite on this source code and expect it to be this source code later. Source code is an arbitrary construct here. You see we don't use an explicit type, we use text here. Text is the very basic, everything is a text because every source file is basically a text file. So we can visit a text file. This text file here has one line and after it has another line. What we also have here is that we have a path. It seems to be a README. And if we look in the recipe configuration, we see that it is append to release nodes. So what this recipe does is it is a recipe that you configure with a snippet, in this case hello world, and say you're looking for a specific type of file, in this case a README file, and add this line to this file. So there are a few things here. First of all, we have to know that there is a README file. Then we have to add a text to it. And sorry, there's just the two ones. Never mind. And I learned a new method. Thanks, Claude. Yesterday. When there is no README file available yet, then we have to create it. So it's not that easy that we are just looking at every README file and add this line. No, if there's no README file, we have to create a README file first. For that, we have to know if there's a README file in the first place. So somehow we need information before running the recipe. But the recipe visitor just looks at one LST element at a time. That's not a problem because we have something that is called a scanning recipe. Let me quickly get to this. Yes, the scanning recipe. Scanning recipe is a special kind of recipe. A scanning recipe has not only the one phase, looking at the code and changing the code, it has two more phases, which exactly mirror this use case. They have a scanning phase. That's a phase where it looks at every element in the whole project and can pull information out of it, store this information safely, has a generate step where it can generate new source code, and then finally we visit it. So that way we can check if there's a README, if there's no README, we create README, and in the end just append the stuff there. This scanning recipe needs something that is called an accumulator. This is just a class. You can define it on your own. It doesn't need anything. Just a data class. It could be a, no, it couldn't be a record because it is mutated, but it can be a value or something like this. Depends on your use case. And what we're interested in is if we have found something. We start with false because pre-assumption, no, there's nothing available. And we say, okay, this recipe uses this accumulator, import this properly, and implement the methods you're needing. So this accumulator class here, there needs to be an instance, of course, because we're in Java. We created initially. We could set up something like, I have a configuration here that tells me I have to use not a README file, but have to use a different style of file, different name, different whatever as configuration. For the initial value, we don't need that here. We just say, okay, we start with the false here. That's what the initial value is. It's basically the initializer of the accumulator. The accumulator is not stored within the recipe. OpenRewrite score in the execution context deals with storing and safely restoring this and handling it concurrently. And what we also require for a scanning recipe is this scanner phase. This get scanner, you see that is a tree visitor. It is the same thing than the visitor that does the manipulation. Only precondition here, a scanner is not allowed to change code. It's just there to extract code. Think of it like the query language for your LST. What we want is, I just copy it from the left because I don't want to type it in. we use another tree visitor. We write an anonymous instance here. What you see a lot in OpenRewrite is that we are creating a lot of anonymous implementations here because there are few standard building blocks to use again. Has a dependency, find a file, rename something, but looking if the, search for me a specific file, there's a recipe for it, but yes, probably it's not the most efficient one. What we are doing here is we are looking at every source file. So we are looking at stuff that is parsed. We are parsing markdown files as text files, as line-based text files. Therefore, we know it is a source file. And if we have a source file, then we know it has a path. If we know the path, we can say, is it a README? Yes. Okay, then we have probably found a README. What does the scanner do? It scans every source file that is available in your project, checks if the name is README. No. Okay. If so, if it is, then we just set this value to true. So what we then need is the second step I mentioned. After we know there is no README available, we have to generate a new one. So now we are generating the first LST element, and it has to be in a special place because all the visitors later that are configured need to see this new file probably. Think of an Spring Boot application that changes your properties files. There has to be a property file. And if one of the recipe creates this property file and everybody depends on there is a property file, then it has to be generated first. Third thing, we are now no longer populating the accumulator. In fact, it would be considered an error if you're trying to manipulate the instance here. We are now in a state that we are just reading the accumulator from the after the scanning phase. If we already found a README file, we have nothing to do. We have no new file to create. So we take the empty list. Yes, it is an old school style of creating an empty list. That's because all of the OpenRewrite recipes, at least in the core, are built on Java 8 for backwards compatibility. Because if you are not allowed to execute on a Java 17 machine in your bank system, but you require your migration to requires in Java 17 version, then you might have a problem there. That's why everything is Java 8. Feel free, if you don't have this limitation, use Java 17, Java 21, whatever you like. It's working. It's just to meet the very lower bound for everybody. What we now do here is recreate a new plain text file with a specific name, a specific content. We do this with something that we probably see later again, depending on the time. It is called a parser. For every language, for every semantic that we support in OpenRewrite, there is a parser. The parser takes an input string, that is the contents of the file, and produces the LST element out of it. It's basically the reading phase that OpenRewrite does before. We just say, okay, we just want an empty README at the beginning. So empty string, we want it to be called releases. How does named releases? Weird. We have to double check the test in a minute. And then we are done. We are collecting here a list because the generate phase is not limited to just creating one file for recipe. It could be possible that we have to create 5 or 6 or 7 files. Think about an Beans XML and Web XML migration to the Spring Framework style. It's not just one initializer. It's probably 10. So all the initializers have to be there. After we have the file created, we are now back in the basic recipe area where we create a visitor here in the getVisitor method and manipulate files. And first of all, of course, we check, is this the release file, markdown file that we want to append something on? If not, we are just returning the tree directly because nothing to do here. If it is the release markdown file, we guard against double changes here. That's something is, if we don't have this line, we probably end up in a second cycle and probably add the same message in the same file again. So that's something you should guard in your test harness. Always guard the there's nothing to do and the change already has done phase, because that will bite you otherwise. And then we append the message here. A couple of small remarks here. Every LST element has this wither methods. We see that a lot, that a wither method is called and the result is not stored. If you not store this result of the wither method or use it as a return value, your change to the LST is lost. It's very frustrating from time to time. If you have very large methods and forget to store your manipulation, then it's lost because it is creating a new instance. Same thing we from time to time see is that people mix up returning t with return this one. What might be the difference here? It could be a performance improvement. With this super method, we are handing it down the tree. If we are following recipes or following LST elements, remember, we have a source file. After the source file, there comes a compilation unit in terms of Java. In the compilation unit, there comes a bunch of classes. In the classes, there comes a bunch of statements. The first visit method that returns the same tree and is not forwarding to super is the breaking point. If you not call super on a compilation unit, your visitors will never visit the method declarations, which can be a high increase in speed. If you're just interested in the source code path, your visitors don't have to visit all the way down to the Java method invocations. Because why? Just don't call super at this point. But be very careful here with the returns, with the super call here, because it's probably a bad idea. What would be the difference for there's a second problem here. If we do this. It is the same content. So that's a very confusing part because the git diff will show nothing. But we enter a second cycle because with this diff with, it's another instance. Once we return a different instance from this method call here. So this instance differs from the instance returned. This recipe is considered to have done a change. And we only terminate an OpenRewrite when no recipe is considered to do a change. If you have one recipe that is always doing nothing to the LST element effectively, but returning a new LST element, you're ending in an unbounded cycle. And I know very well because this happens nearly weekly to me. Yes, that's it for the scanning recipes. The scanning recipes are very powerful, very, very powerful when you have something to do with configurations. You have to deal with configuration values in your configuration files, with the existence of different files. So if one bean exists, one bean definition, I do a complete different thing because I don't have to define this again, or I can use it and rely on it. So every time you need context, your recipe needs context from somewhere different. That's not in the LST element you are differing. It's also very common to produce documentations like we did. The release markdown is basically documentation. For dependency analysis, for code migration that needs context in terms of we have a special dependency available also. Yes. 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 And that makes second cycles and scanning recipes even more confused, because you also end up with a different accumulator result. Even the generate phase is run twice. So if you're creating the same file twice, your OpenRewrite testing harness will tell you, hey, we have now 2 README markdown files. So because there's no real file system, the file system would tell you, no, there's already one. So you would have a runtime error, but the testing harness will already tell you you tried twice to create this file. Play around with it depending on the recipe. If you have no reason, just do it in the top. Because for Java, this return type here for the super type is tied here. For XML, for example, the visit XML part, for some reasons, I don't know, historical reasons, returns XML, but gets XML tag. So there it is confusing because it's called the super method, and then have to cast back. So do whatever you like. Important point is call visit when you want to traverse it down the tree. Yes, it's I think the breadth first and depth first is even more important in the scanner phase. But yet there are cases where it is of interest if you're digging deep down and changing elements deep down first or on the same level first. So call it first or call it last. But that's a rare case, and I will not call it bad design because sometimes it has to be this way, but reconsider twice if you really want to write a visitor that somehow depends on the changes it has done to a previous LST element. That's basically what you're describing. Yeah, and getting the wheel deep now. I have no sense of time. I lost my clock, to be honest. Let's have okay, so I have to leave the presentation mode once. We could now dive a little bit more. I let you decide. A little bit more into how we are creating new LST elements on the fly, or something called traits, which is a style of, I think, more easily write visitors because you are not so tied to the LST elements. So, okay. And traits it is. So, rotation mode. We have here in basic, oh, it's even two things here. It's always also data table that we will see later again. We have a find spring beans recipe. It's a kind of made up example, like to release this as well, but the idea is to find spring beans and document the spring beans in your application. Within your application, it's probably easy to do. If you run this recipe and collect this data table on your whole organization, it's a different level. And that's most of the recipes are about. So how do we want to start? Let's have a look in the tests first to provide you that we have tests here. And to get you a little bit of the idea. So the idea is we have a configuration with beans defined in there, and the idea is to find every of them. I should have to put it a little bit up to find every one of them and mark them. Does anyone know this comment thing here? It's called a search marker. We have a lot of markers. Markers like every Java source file, for example, has a reference to its Java project it belongs to its source set it belongs to. If Maven or Gradle is involved, you have a Maven and Gradle resolution result because you probably have to know your class path. And the search result, the search marker, this one denotes that this LST element is something that the recipe is marking as you looked for this thing here. It is very common in every recipe that has something with find in its name, because it's always a find a method invocation, find a method definition, find a class definition, and so on and so forth. And with this marker, this is an LST change because this marker renders, and you can use this as a precondition, for example. So precondition is there a method call to this method? Yes, because there's a search marker found, then we can do our magic stuff. What we use it here for is we search for the bean annotation, and then we extract the name out of it. And that's the interesting part, because sometimes we use the default without everything. Sometimes there's a name. Sometimes there's nothing given. Then Spring Magic relies on the method name it is generating. It is just the programmatic way of doing here. And as always, include a case where it is supposed to do nothing. There's nothing. Here's nothing to denote. What we use in our test case here, in our recipe here, is something that is called a trait. A trait is an arbitrary construct, as the Jonathan Snyder denotes it. What does he mean with it? It's an arbitrary construct in terms of something that makes sense in your source code. I just scroll it a little bit. And this time we search for annotated. You might recall that we are visiting method definitions, fields, and class definitions, and so on and so forth, and all of them can be annotated. So on a meta level, if we are looking for things that are annotated, they belong to the same group. That's what traits for. Selecting stuff that is of different type, but belong to the same group. In this case, it is annotated with @bean and visit all of these elements. The neat thing is that we no longer have to deal with a visitor that is visiting class annotations, method annotations, and so on and so forth. And is it what we want? I just have to spin forward a little bit because all of this is more or less meant to be a workshop of, you know, you just roll it back with Git. I just deleted it right now. Show, compare with revision. So here we are. I just removed the comments. No. Thanks again. We are now looking at everything that is annotated with a matcher and say, okay, we don't want to have the list of this stuff, but we want to have a visitor visiting all of the members of this group. And we are then going through it. First of all, we say, okay, you're annotated, you're an annotation stuff. Get me your default. Get me your default name. Default or name. Convert it to a string. And to be honest, this is just the ugly way of dealing with the default naming of annotations. You can ignore that. First of all, more important to know is that we are extracting the bean name here. So either it is the default, it is the name value, or the method name. And then we just call this search result.found. I found this tree here, and please denote it with the method name here, with the bean name here. And then we are done. So this is a trait. Whenever you encounter something that is not of the same type, but follows the same semantics, try to use a trait. It is a little bit complex to wrap your head around it, but if you remember the recipe, the default, the normal visitors, these few lines here would be way more complex because all of this logic has to be not duplicated, but multiple times executed on different LST levels with different getters. What can we do with all of that?
Question. Can you have multiple matches? Like, there's this @qualifier notation that also can set the bean name, right? Can you have multiple matchers?
This is something of the matcher. Underlying here is an annotation matcher. An annotation matcher is something that can work on either a full qualified name or, for example, which probably doesn't make sense. Yeah, we find a lot of them, but also support to some extent some I will not call it regex, but similar. Not everything is supported there, but a lot of stuff is. What we can do with it now is we can run run a few recipes. I show it to you, this one is combining all of it. And if you're interested in the details, next Wednesday, I'm on the OpenRewrite podcast and YouTube cast, where we discuss exactly this, because this is solving one of our problems. As you may see, I have a lot of OpenRewrite repositories here. All of them are somehow connected. One of our problems in OpenRewrite is that we have problems to chip out new releases because our release train needs a lot of cycles. I told it out there, our release train needs 12 cycles, and every cycle has to wait until every artifact of the previous cycle is publicly available on Maven Central. So that sums us up to, in best cases, 3 hours of release training, sometimes 2 days of release training, thanks to Maven's unpredictable speed. Maven Central's unpredictable speed. Maven is rather great. What I want to run now is I quick started here. I look for a recipe. So, recipe search, because I know what it is called. It is the release metro plan. Yes, I want to activate it and I want to run it. What we are now doing here is we are running this recipes. Sorry, I forgot. No, I'm not allowed to run it in parallel for some reasons at the moment because there's a bug in the CLI. What we are doing here is, perks of using the development version. We're not only executing OpenRewrite once, but we're executing it to some extent in parallel. On my local machine, it's not allowed to run in parallel, but in the SAS, for example, it would be allowed to run in parallel to run this recipe. And this recipe is looking for project IDs, so group and artifact IDs of every project, looking to parent and child relationships, and is looking for dependencies. You might guess what the release metro plan with this information might lead to. It is a big graph representation of what artifact is depending on which artifact. And what we are doing here, we are creating something very similar here. We are producing search results here. As well to the search results, it is nearly done now, is that we have created data tables. Data tables are the output of the query stuff. And you see that we have here 22,000 dependencies in the Markdown generator. That's because it is nearly including a lot of stuff. That's the magic behind the documentation. And it is now creating this data table. The data table is whenever you have a find recipe which produces search results, it is usually, that's the best practice, as we're producing a data table. A data table is a columnar representation of data that is extracted from the LST. It can be arbitrary, and it's on the recipes control to insert it. And if we have a look here, let's have a look here, because I also have copied them here. It is here under data, dependencies in use. It's too big to be displayed, but what we have here, we know which repository it is from, which branch, which project name, which source set, which group artifact, and version it is depending on, and what it is using as the dependencies. Later on, you can write your own data analysis stuff on that. We usually do it with Python. I have done it here with Kotlin notebooks to build your very own representation of it using these data tables. And if we have a look here, so probably you might see the problem, why it is taking us so long. And this is just OpenRewrite. This is not the modern internal stuff that is released afterwards. That's another 10 cycles. Yes.
Kind of polywrap to match the release versions while you are releasing based on the dependency wrap.
Yes, because let's have a look at some one of the internal one. Yes. For example, let's pull something out here. Rewrite Apache. Rewrite Apache is a recipe artifact that is dealing with a lot of Apache projects to migrate. Because were available later than some others, it reuses stuff from, let's say, analysis. I don't know what it is reusing. Let it be an dependency usage or a method usage recipe where someone said, no, I don't want to rewrite this recipe again. I just use it. I saw it in documentation. Good stuff, but it leads to something like this in the end. And that's an ongoing problem because we cannot simply move recipes from left to right without breaking users' code. Yes, there are no cycles. Really. I'm always surprised as well, but yes, there are no cycles. Yes, it is checked automatically, but every time we have to roll out a bug fix, there's always this uncertainty of do we really have had everything released or do we missed one of the other recipes? And the big problem is if you're breaking the API or the semantics, someone, if it is all available long enough, someone will use it and you will break someone's code. That's the problem. We used to, but it's no longer capable because most of the releases 2 days, 2 hours is the best. It wasn't reached the last 6 months. It was always 6 to 8 hours. So we have to do smaller releases from now on, but for that we have to know which models we have to release. Even semantical. So two words to what we have seen. We have seen OpenRewrite. All of them is OpenRewrite. Even the data table stuff and the CLI stuff, at least for open source projects. And it has the Gradle Maven integration. It has the CLI integration, which is free to use. It comes from a few different vendors. Broadcom, Amazon, Netflix, not Netflix, sorry, Netflix this time not. JetBrains, Microsoft, IBM Watson, Tanzul, nearly everybody of the big. We used to do open source and we used to redistribute open source. Guys took OpenRewrite and built it into some of their applications and started to sell it for ridiculously prices. And that brought us to the problem that we have to compete with Amazon, with our own product, fighting against our own product sold by Amazon, where not technical people started asking, why should I use your product instead of the very mature Amazon product? They're thinking, no, they are not mature. They are just bigger than us. That made us doing an license change. It's not a license change because we haven't changed the license of existing recipes. We have started writing recipes under a commercial license if only modern employees worked on it and the customer paid for us to do this. So Spring Boot release will be behind a paywall for a few months until the next release will be available and it loses value and then everybody can use it again. It's basically to guard us against hyperscalers selling our product, and sorry for that, it was now a choice to do so. But what's the real difference is not that we have a few more recipes than the others. what we can do is we serialize this LST. You might have noticed that we have executed this recipe on all of the OpenRewrite repositories in 2 minutes? Something about 2 minutes? No, 1 minute? If you ever have used the OpenRewrite Gradle or Maven plugin, you might notice that even for a pet clinic, it takes up to 3 to 5 minutes to migrate once. That's because that's the time the LST needs to be created. And if you have a big organization, that's not feasible. And that's the selling point. That's the only part that is kept closed source and will always be closed source. Once the hyperscaler agree on a better business model with us, we are happy to open up the recipes again. And a lot of the recipes are open to in the third version called Modern Source Available License. It's free to use for everyone on their own code. So if you're writing in-house code, you're free to use. If you want to learn something, the documentation is real good and getting better from week to week. Same for Modern. Feel free to play around with app.modern.io. That's Modern public available. The GitHub repository is probably the best location to start from because our source code is an even better documentation than our documentation because our documentation is auto-generated. And weekly, with some exceptions, we do a webcast on all the things we are doing, sometimes with customers, sometimes with open source contributors, sometimes doing way different things like chatting with the open operator guys, how they use the OpenRewrite and how to plan OpenRewrite. So thanks for that. I don't know if I'm overburned. I'm done it for now.
Well, Merlin, thanks a lot. Well, you took your time. It was very well used, I would say. It was a deep dive. Some questions were asked in between. Are there any questions at this moment?
So the question was, we have a known problem with multi-module builds.
Okay.
And that's basically the problem that every source set is handled on their own, and it was decided way back in Rewrite 4 point something.
Okay.
The question was if there's something with wrappers around it. To be honest, we struggle to find the right way out of it. That's
Okay.
real. Some engineers internally mentioned just throw away the Gradle and Maven implementation completely and rewrite from scratch. Probably that is the way to go because we don't know where the problem is. The problem is mostly if you're changing dependencies somewhere, it's not re-resoluted. You're working on the old Maven resolution result,
Yeah.
which is very uncool if you're migrating from JavaX to Jakarta because the classes are no longer available because they're in a different namespace now. So this problem,
Okay.
there's no cool way around it, and I fear that will be a little bit longer a known problem.
Okay. Cool.
No, not cool, but there's a different solution called type tables to store your minimal information inside your artifact.
Okay.
That overcomes a lot of these problems, but it's not a total solution. It's more for bug fixing stuff, but it might work there.
Okay.
Any other questions?
So the question is if I recommend going with a scanner to gather information or send information around, or go with the cursor and put a message to an LST, so-called. The messaging stuff is the older technique. And the problem is that the messaging stuff is stored next to the LST. And the LST is only in the Maven and Gradle integration, always in the storage, in the working memory. And the other implementation, it is chopped into pieces and streamed inside. And now you might see the problem that if you're putting a message somewhere, it might not be in your working memory when you need it. And that's basically the shortcoming why scanning recipes and storing that in the execution context next to the LST with the scanning recipes were the initial idea behind that. Because there was the feeling that that might be a very common use case that you need information from different source files.
Cool. Thank you.
Nevertheless, this messaging stuff is great for if you're saying, I have generated this file is outdated, this is deprecated. So whenever you're flagging a file and you know this information is only available just for once, take this, but limit yourself to little strings. No real data value, please.